Okay, so let me share my screen first. Okay, is my screen visible to all of you?
Yes, sir. Visible, sir.
Yes,
Okay,
sir.
okay,
Visible.
HOSPITG.
okay. Just a second. Just a second. Let me start recording also. Sorry for that. Just a second, so that we can. Okay. Yeah. Great. Yeah. Great. Okay. So this is the peer deck. You have to join this peer deck slide. So you have to just enter on your browser joinpd.com. Okay. And after that you have to enter this code HOFYD and G. Okay, so just join it fast so that we can start the towards the question and all things. Okay, 11 of you have joined this peer deck slides. 12, 13. I hope everyone is familiar how to join this, right?
Yes, sir. Yes, sir.
Okay, okay. Then join it fast so that we can start. So everyone is ready for the quiz to exam.
Getting ready, sir.
Okay, 20
But
of
this
you have
time we are
joined.
having,
Yeah, yeah, please.
but this time a little bit of time is there, sir. After completion of eighth week to the quiz, the number of
But
days available is
week 9 is due date of week 9 is also in the next week.
yeah,
So
9, 10 will keep coming, sir.
yeah, 10th due date of week 10 will be after the quiz 2 exam. But
Yes, sir.
due date of week 9 graded assignment is on I think next
Next Wednesday.
Wednesday. Okay.
Yeah.
So accordingly, I mean, just give your best. Okay, so 21 of you are joined. I think there are 29 people except me, 28. So 7 are remaining. So please join it fast so that I can start the session as soon as possible.
And sir, and week 9 is a bit lengthy.
Yeah, week 9 is bit lengthy, but as per the uh, course, we have to release the content on every Friday, right? So because if you see, if we will extend the due date of week 9, then it will be hectic for everyone because end term exam is on 30th April, right? Then it will be,
Right, sir, right.
yeah, so it will be too difficult to manage because after 2nd April we have only 28 days, right? In those 28 days
Right, sir.
you have to cover all the 4 weeks, then revision session and all things. So I
Sir, only
mean,
3 weeks, no, sir. 9, 10, 11 only. The 12th week is not there, no, sir. Only
yeah,
11 weeks are there.
only 12th I
Sir,
think
in the
is
stats, 12 week are there.
Oh,
okay, okay, I will check for the 12th week. Okay, I will check for the 12th, but 11 is for sure. Okay, so 21 of you have joined. I think there are 29 people, so please join it fast so that we can start. You know how to join, right? You have to just enter on your browser joinpt.com, and after that you have to enter this code HOFYDG. Okay, yeah, someone saying yes, please go ahead. Okay, 22 of you joined. Okay, so I will wait for 1 more minute. After that we'll start the session. Okay, can you retry, just refresh? Okay, just refresh and again enter joinpd.com. Okay, after that you will, I mean, you will get something, enter a code. Okay, so you have to enter this code. Just try to rejoin. Yeah, I think Nan is saying right, so just use your Student ID, I think. Okay, 25 of you have joined. 25 of you have joined already. Okay, okay.
Week 12, it says revision week, sir, in the
Oh,
syllabus.
okay, 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 okay. Yeah, yeah, yeah. Okay, so 25 of June. Okay, so I will wait till 6:25 p.m. After that, we'll start because it's already half an hour. Okay. Is there
Sir,
any session after 8 p.m.?
Yes, sir. Maths
Match
two.
two. Match two. Okay. Okay, okay. We'll try to finish within the time. Okay.
sir,
That is the doubt clearing session by
so it
TS.
is a session by TAs. I believe if you
TA.
can continue, and those who want to join Maths 2, they can
Yeah,
watch
yeah,
later.
yeah, yeah. I mean, it's okay. So what we'll do? Okay, we'll continue, and those who will join the match too, they can watch on YouTube also. Okay. Okay, we'll try to finish within the time also. Okay. So let me start the class.
Sir,
Also, those who have not joined, just enter this peer deck. Just enter joinpd.com on your browser. After that, you have to enter this top right corner code HOFYDJ. Okay. So
sir,
this is
one
the
thing was
yeah, yeah. Please
in
go.
the practice assignment solution for the week 8 is
Hmm.
wrong. It's the same PDF as week 9. Please upload the correct PDF for week 8.
Week 8.
Yes, sir. Week 8 and week 9 PDF is same
Okay,
for
so they
I think.
have uploaded the week 9 PDF.
Yes, sir.
Okay, okay. We'll check. We'll check. Thanks for the information. We will check and we'll.
This is actually a mishap that week 7 is done for as week 8.
Okay, okay, okay.
Yeah.
Okay, okay. We'll check. We'll check. Thanks. Thanks for
Uh,
the information.
Excuse me, sir.
Yeah, please.
Sir, while going to the dashboards of in the portal, week
Hmm.
5 and 6 have been marked absent with regard to the scores of graded assignments.
So you have submitted that one.
Yes, sir, I have submitted that.
Okay, so is it for everyone or it's for only you?
Yeah, it's for Yes, most of the for people. everyone, sir. Most of the people. Even
Okay,
for
No,
so
no, grade
weekly.
5, graded assignment 5, 5. It is coming, sir. 5, 6, it has already, marks have come out.
okay, so might be okay. I will ask to the support team. Might be there is some issue. Okay, and there is issue. I think they will sort out. Okay, I will ask to the team. Okay,
So
no
even
issues.
for the weekly activities, what we have, they are also marked absent. Sir, week
Extra.
5 and 6 assignment come today only. You can refresh the page. I think you will be able to see that.
Yeah, yeah, that might be case also. Okay, thanks. Yeah, so just recheck with okay. Else, I will ask to the team what is the issue. They will update. Okay, okay. So should we start?
Yes, sir.
Yeah. So those who have not joined this peer deck yet, just enter joinpd.com on your browser. After that, you have to enter this top right corner code HOFYDJ. Okay. So let me start the first question. Okay, so it says x1 up to x100 is IID random variables, each with expected value mu with 3 and variance, which is nothing but variance of xi is 9. So it says approximate the probability that x1 plus x100 greater than 100 by using the CLT, right? So you have to write your answer in terms of abject. Abject value is not given here, so you have to write. Suppose you are getting abject of 2, so just write the answer in that format. Okay, so basically what the meaning of CLT is there. Okay, so in CLT just try to do like this. Suppose I have random variable x. Okay, so x minus expected value of x divided by standard deviation of x. Okay, will follow what? Standard.
Normal.
Okay, so while using the CLT, okay, always using the CLT, you can consider it as a trick or it's a standard procedure. just convert the things, just convert the your I mean equality or inequality inside the this bracket as in form of the standard normal. Okay, just suppose I have written x1 plus x2, so write down the x1 plus x2 minus expected value of x1 plus x2. Okay, divide by standard deviation of x1 plus x2. Okay, this will follow standard normal variate. And see, since it's a probability of something, suppose I'm getting let's say z less or equal to some value, so I can find out this value from the normal table. Okay, is this clear? I mean, are you getting my idea?
We'll
Okay,
try, sir.
yeah. So just try to this question. Okay, I'm going to give 3 minutes. After that, if you feel, we'll extend the time limit. Okay, so just think, we have done thing in week 7 also. If x1 is suppose I'm saying x1 x2, suppose I'm saying x1 x2 is IID with 3. So what will be the expected value of x1 plus x2? Anybody?
N mu, sir.
Okay, I just said about two random variables, so it will be 2
6.
plus 6, right? 3
6.
plus 3. The same things you have to think. Just consider this x1 plus x2 plus x100 as a single random variable. Okay, and then try to convert it as standard normal form. Okay, and how you can convert in the form of standard normal variable? You have to subtract the expected value, divide by standard deviation of that variable. Okay, so you have to find out the basically expected value of this whole summation and variance, I mean square root, I mean standard deviation of this whole summation, and then try to find out the that one. Okay, so basically central limit theorem is, I mean central limit theorem is nothing but, suppose I'm saying x1 x2 xn is IID some x, and with expected value of xi is mu, variance of xi is sigma square. Then I'm doing some scaling. I mean, I'm assuming like y as a random variable, which is nothing but x1 plus x2 plus xn divided by square root of n. So this will converge to normal 0 comma sigma square, right? This is the central limit theorem. Means what is whatever your x is, whether it's a binomial, it's a Poisson, anything. When you will increase your n, when n will tend to infinity, when n will be large, the approximate probability will be I mean x1 plus x2 plus xn divided by square root n will be normal 0 comma sigma square. Okay, so this is the something, because okay, we'll discuss. Okay, so I
So
have
what we
received,
have to write in the box, like if we are getting the value of z, then
just no, just you have to write in the form of fz, whether you are getting fz2 fz3, just write like that.
so
Okay,
like I'm getting it negative, so I have to write it negative only.
yeah, whatever you are getting. Okay, just write. Okay, I think I need to extend the time limit. Okay, 3 minutes or 1 minute?
At least one.
At least 1 minute. Okay, you are saying 3 minutes.
Sir,
Mm-hmm.
sir, for FZ we have to refer to the tables.
Yeah, but here you have to just write down the in terms of fz. No need to table here. Okay.
Okay.
Yeah. Uh, yeah. You have to just write down. Just I said, suppose you are getting fz of 2, so just write down the fz of 2. Okay, I have received 14 responses. As in the session, there are 33 people. 31 of you have joined this peer deck. So rest of the two people just enter joinpd.com. on your browser. Okay. After that, you have to enter this top right corner code HOFYDJ. So just join it and try to solve with the within the given time limit. After that, you will gain some confidence kind of things, because I'm able to do within the given time limit kind of things. So it's good for you also. Okay, 17 you have given the responses. Wait.
Sir, in the graded assignment, the Z values are not given.
Sorry.
Graded assignment for week 8,
Hmm.
you don't have the Z values generally are given, right? F is Z values.
Okay. Yeah, yeah.
I don't see that. I'm not sure if I'm missing something.
Is it? Let me check. Okay, I will check. I will check for that or the same. If it's not, then you can also say from. Just do Google standard normal table values. Okay. From there, you can see the values also. But during the exam,
Sir,
all the values will be displayed.
sir, in two questions they are given, sir. Question number 8 and 9, it is given.
Okay.
But for some it's not given. But yeah,
Okay.
I
Okay.
look it
Okay.
up.
It might. Okay. There might be a missed out
6 and
some.
7 they are given.
Okay. Okay. We'll check. We'll check. Okay. Let me see the responses. Abject. I think there are some background noise. Something. Yeah. Yeah. Thank you. So abject minus 6.66. 1 minus. See, small abject means what? It's a something you are writing PDF, right? That's the not thing. Capital abject. So 1 minus abject minus 20 by 3. 1 minus abject minus 6.66. Okay. 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 Someone has written the direct value also. Okay. So let's see. What's are given the things? X1 F2 Xn are IID, right? Okay.
Yes, sir.
So x1, x2 up to xn, sorry, x100 are, it's the IID x with expected value of xi is what? 3,
Mu.
and variance
No,
of
3.
xi was
9.
9. Okay. So it says using the central limit theorem, we have to approximate the probabilities that x1 up to x100 is uh, greater than 100. Okay.
100.
Oh, sorry. Yeah, so it's 100. So what's the funda? I have to convert these things in terms of as a standard normal variate. Okay. So can I let, so okay, I'm going to let as S. Okay. As the sum, I mean in terms of sum, it's a S100. Okay. So far so good. Now to convert these things, so what I have to, find out the S minus expected value of S divided by standard deviation of S. It will follow normal 0 1. So far so good.
Sir,
Yes.
so this is like normalization, sir.
This is, yeah, correct.
Yes.
So this step is clear. What we have to do?
Yes, sir.
Yes, sir.
So what is the expected value of S? Means expected value of x1 plus x2 plus so on x100. Correct.
300.
Expected value of each xi is 3. Then what will be the expected value of x1? So can I write down the like this? Expected value of x1 plus expected value of x2 plus so on expected value of x100. Correct.
Yes, sir.
So that means 3 plus 3
3.
plus so on plus 3. That means
100
100
times.
times 3, right?
100 times.
So it's a 300. So one step we have done. Next step is we have to find out the standard deviation of x. So for this, we can find out the variance of s, right? First. Okay. So variance of s means variance of x1 plus so on x100, right?
Yes,
Since
sir.
all the random variables are IID, that means independent and identically distributed. So can I write down the variance of x1 plus variance of x2, as these all are the independent, right?
Yes,
If
sir.
xi's are not independent, then there will be some covariance term, right? So what is the variance of x1? Is the 9. Variance of x2, 9 plus so and so on, 9. So it's 100 times 9, right? So it's 900,
Yes.
correct? So
Yeah.
what will be the standard deviation of s? 30.
30.
Okay. So far it is clear. Now we have to find out, we have to approximate the probability this x100 greater than 100, right? That means we have to do probability s greater than 100, right? So what is the normalization? So s minus expectation of s divided by standard deviation of s, right? This should be greater than
Sir,
100 minus expected value of s divided by standard deviation of s, correct?
Yes, correct.
sir,
Okay.
can we put it in the formula of S minus N mu, that formula?
S minus,
Like S minus N nu divided by root over N
yeah,
sigma.
that's the same thing. What is the n mu? N mu is the
Yeah.
mean of this variable, right?
Hmm.
Okay, that's why I'm trying to explain. In CLT, what you have to do, just do the things whatever your random variables, just convert in the form of standard normal. Okay, suppose suppose I'm saying instead of x1 plus x100, right? Suppose I have x1 plus x100 divided by 100. Okay, this can be also possible, right? Are you
Correct.
getting? Okay, so what I'm trying to say here. Okay. So what I'm saying, see here we have to approximate the probability like this. Okay, for this one, it can also possible. Let's say I'm saying s1 as the x1 plus x100 divided by 100, right? So what
Yes.
you have to do? So what I can do, s1 minus expected value of s1 divided by standard deviation of s1 will follow standard normal. Okay, so you have to find out the expected value of this mean, variance of this mean, and then you have to do this transformation. Okay, so what,
Correct.
so by using the CLT, so we have to find out the this, we have to approximate the probability these things, correct? So we have s. Okay, so what we can do, we can do s minus expected value of s divided by standard deviation of s greater than 100 minus expected value of s divided by standard deviation of s. So far it is clear for everyone? It
Yes,
is
sir.
okay? Yeah.
Yes, sir.
Okay, so
Yes, sir.
what is the expected value of s? 300.
300.
What is the standard deviation of s? 30, right? Okay, so
30.
what it will can I write down in terms of z?
Yes, sir.
Okay, so z greater than 100 minus 300 divided by 30. So probability z greater than minus 200 divided by 30, correct? So probability z greater than minus 20 by 30. Since we have to write down in terms of fz, so what is
20
the
by
fz?
3.
Fz basically it represents the probability z less or equal to z, right? See, what is the CDF? What is the f of x? Capital F x is nothing but probability of x is less or equal to x, right? Since these things is in form of greater, so what I can write down? I can write down the 1 minus probability of z less or equal to minus 20 by 3 or not.
Yes, sir.
Okay, so it will be 1 minus fz minus 20 by
20
3.
by
So
3.
this should be the answer which you some of you have already given. Okay, so this thing is clear for everyone.
Ah, yes,
Yes,
sir.
sir.
Yes.
Now we are able to understand.
Okay,
Sir,
yeah, please.
sir, so any distribution, if we subtract it from that expected value and divide it by standard deviation,
Yeah,
we'll get normals.
correct. When n is large.
Yes, sir.
Okay, that's the CLT says. Okay,
So this is same as normalization, sir.
normalize. Yeah. So the thing, yeah, we have done the same thing here. Instead of s, In the solution, it has written as S100. You can take as Y100, W100, anything. The same thing we have done. Okay. So I'm moving to the next question. Okay. So here, one more thing you have to keep in your mind. Okay. The same thing is there. You have to use the CLT, but instead of just a summation of random variable, it's a summation of squares of the random variables. Okay. So there is one concept. I'm going to give you a hint. As a hint, you can see. So that is nothing but it's nothing but, suppose I'm saying you know that one, if exercise follow the normal. Okay. So I'm saying if my random variable x is follow normal 0 comma sigma square, then x square will follow. I think sir has told in the lecture.
Gamma.
So it will be gamma.
Yes, sir.
It will be 1 by 2 comma, I think,
1 by 2 sigma square.
1 by 2 sigma square. This is
Yes.
the thing. Okay. Okay. So this is the axis. One thing. Another thing. This is for the one random variable. Okay. And suppose I'm saying x1, x2, so on xn is following gamma. Let's say alpha, beta. Okay. Then and it's IID. Let's say it's IID. Then what will be the summation of these things?
Gamma and alpha,
Gamma,
gamma beta.
beta.
Correct. Gamma n times alpha, comma, beta. So these two are things you can use as a hint. And here you have to use, right? Like here, see, x size are IID normal. So what will be the x1 square? X1 square will be gamma half, comma, I mean these things, right? This thing you have to, I mean here your x1 will x1 square will follow gamma. After that, what you have to do? You have to, okay, we are adding the 100 IIDs gamma variates, right? Are you getting my point?
Yes,
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 sir.
sir.
Okay, because see x1 to, okay, so from here, as you can see, what we have to find, x1 to x100 normal 0 comma 2 things are given to me. We have to find the probability of x1 square plus so on plus x100 square, right? So thing is that if x is follow 0 comma sigma square, so x square will follow half comma 1 by 2 sigma square, right? Are you getting?
Okay.
See,
Yes, sir.
I'm saying x1 follow normal 0 comma 2. So what will be the x1 square? It will be gamma 1 by 2 comma 1 by 4, right? Similarly, x2 square, right? Are you getting?
Yes, sir. Yes.
So now one more thing is, once it will follow gamma, some alpha and some beta, then what will be the, okay, not comma, it will be summation, sorry. So sum of these NID gamma random variable will be n times alpha comma beta. Okay. So accordingly proceed. Okay. So you have to enter your answer up to 5 decimal places. Okay. You know what is the mean of gamma, because you need mean of gamma here.
Formula sheet we can get, sir. The formula sheet is available.
Alpha divided by beta.
Alpha divided by beta.
And what is the variance?
Variance
Alpha
is
by beta square.
alpha by beta square.
Great, great. Okay, so let me give you 3 minutes. I think that will be more than enough. So just use that hint which I have given in that sheet. Okay, and don't worry about expectation and variance formulas. All the formulas will be given during the exam. Okay, in the formula sheet. Yeah,
Excuse me, sir.
yeah, please.
So only variance and mean formulas are different. Rest of the question will be done same way as the previous one I've done.
Yes, yes, yes. That's
Like
why I,
conversion of Z,
correct, correct, correct,
that
correct. Same,
that
same,
formula
same.
will be same.
Yeah, yeah. Everything should be
Okay,
same. Procedure will be same. You have to just
okay,
convert the given things in terms of standard normal value. Okay.
okay.
That means you have to subtract the expected value of that random variable and divide by standard deviation of that random variable. Uh, anyone of you wants these things? So I can hold my screen over here also. If the questions is clear to all of you. Okay. Think. I received only 4 responses. Let me extend the time limit.
Excuse me, sir.
Yeah, please go ahead.
Sir, can you please repeat the formula for mean and variance?
Okay, so expected value of which gamma distribution?
Gamma distribution.
Okay, so if your x is follow gamma alpha comma beta, okay. Suppose
Hmm.
I'm saying x is follow gamma alpha comma beta.
Hmm.
So expected value of x is nothing but alpha by beta, and variance of x will be alpha by beta square. Okay.
Just beta square, right?
Yeah, yeah, just beta square.
Thank you, sir.
Is it solvable?
Trying, sir.
Okay, okay. Try and try again. Think. Do you need extra time limit? Because I received
Sir,
only
just half a
One
second,
minute.
30 seconds, sir.
Yeah, 30 seconds.
30
30
seconds.
seconds,
Okay,
one
so
minute.
let me give 1 minute.
Yeah, done, sir.
Done, sir.
So, any one of you want some extra time, or is it okay?
The 10 seconds
Sorry?
is wanted to enter the answer.
Okay, so 1 minute will be more than enough for everyone.
Yes, sir.
Okay, great. Okay, great.
Sir, but we have to remember this, no, sir, when x square, summation of x squares, it
Uh,
asked,
yeah, it's
we should
good
know that the
to keep.
gamma and half of half comma half sigma, I mean,
Half comma half sigma square.
and then you have to remember that n alpha comma beta also for the expected value of the
Yeah, I
summation
mean
of
here
squares.
things should be given actually in the question. Don't worry about exam. If it's something like this there, then we'll give you as a hint. Okay, but it's good to keep in your mind. I mean, suppose you have, I mean, you know the things already, right? So you will do the things very quickly.
Okay.
Okay, in terms of, okay. So anyone want extra time limit, or is if anyone of you is trying, so we can wait.
14
And don't
responses.
hesitate to ask time limit and all things. So sessions is conducted for you. Okay, so you can ask, yeah, I need more time, I am trying, like that. Okay, so should I proceed or should I wait? Anyone?
So proceed.
Okay,
Yes,
great.
sir.
Proceed, sir.
So 0.23885, 0.23885, okay, 0.24, 1 minus subject 0.5, okay, 123, 27.5. Okay, so let's see the solution. Okay, so what the question is, x1 up to x 100, okay, so is normal 0 comma 2, correct? These things are given, right? So x1 up to x 100 is IID normal 0 comma 2, okay, and we have to find out the we have to approximate the probability. Okay, x1 is square plus so on x 100 is square greater than 220, right? 220, yeah. Suppose instead of square, it's simply given that probability of x1 plus x 100 greater than 220. So you can directly do, right? Means what will be the expected value of uh, x1 plus x 100?
0.
Inputs.
0, right? Similarly, variance will be 200,
2.
right? So what you can do in those situations? So it will be what will the variance of x1 plus x 100? 200, right?
200.
Correct. So what you can do? You can do, like, let's say this is z. This should be greater than 220 minus 0 divided by square root of 200, right?
Yes, sir.
These things we have to do, but here we have given the squares. As we know, if x is follow normal 0 comma sigma square, then x square will follow gamma distributions half
Half
comma
comma
2
half
sigma
sigma
square.
square.
Okay, this things is something we know. So if x1 is normal 0 comma 2, okay, so what will be the x1 square?
Gamma
Gamma
half comma 1 by 2
1
sigma
by
1
2,
square.
by 4.
sigma square is already 2, so it will be gamma half comma 1 by 4, right?
Yes, sir.
Since all
Yes, sir.
variables are IID, so I can write down the x1 square up to x 100 square will follow the gamma 1 by 2 comma 1 by 4. So far so good.
Yes, sir.
Yes, sir.
Now we know, if let me change the color so that it will be clear. Suppose I know if x1 up to xn are IID gamma alpha comma beta, then x1 plus sum of these IID random variables will be what?
Gamma n alpha comma beta.
N alpha comma beta, right? So as per this statement, so what, since these you can treat it as y1 up to y100, right?
Yes, sir.
X1 square is y1. So what will the summation of these things? x1 square plus so on x100 square will be what? Gamma.
Follow gamma.
So
100
instead of
into
n
half
alpha, n is 100, correct?
by 2.
So what is the alpha is half?
1 by 2.
Half.
What is the beta? Beta will be same, right?
1 by 4.
These are the parameters. Okay. These are the parameters, right?
Yes, sir.
Now,
Yes, sir.
so it will be gamma. Let's make it 100 count. Okay. So what we have to do? What is the expected value of these things?
Alpha by beta.
Alpha by beta.
Okay. So let's make it as, let's say I'm making considering it as S1. Okay. So what will be the expected value of S1? Alpha by beta, right?
Yes,
Alpha
sir.
is 100 by 2,
50.
50.
beta is 1 by
1
4,
by
right?
4.
It will be 100 by 2 into 4 will be
200.
200, right?
Right, sir.
And what is the variance of S1?
Alpha
Alpha
by 1
by
by 6.
beta square. So
1
alpha
by
is
16.
50, beta square is 1 by 16. So it will be 16 times 50. That will be
800.
800.
800, right? So what will be the standard deviation of S1?
Root of 800.
That means root of 400 into 2. That means 20 root 2. Correct?
Yes, sir.
So far it is clear for everyone?
Yes, sir.
Now, as per the requirement of the question, we had approximate these things, right? Greater than 220, and and this terms was S1, right? Greater than 220. So probability that S1 minus
S1
expected
minus
value of
value
S1
of S1
divided by
divided by
standard deviation of
standard deviation.
S1 greater than 220 minus expected value of S1 divided by standard deviation of S1, right?
Yes, sir.
So far it is clear. So what it will be? I can write down as the
Z.
Z. So 220 minus what is the expected value of S1? As we have computed as 200, right?
200.
What is the standard deviation of S1?
20
20
root
square
2.
root of 2. 20 root 2, correct? Now, so what we have, we got these things at 20 by 2,
20.
20 root 2. So this will become probability Z greater than 1 by root 2, correct?
Yes, sir.
So I can write down the 1 minus probability Z is lesser equal to 1 by root 2 or not?
Yes, sir.
Because I can write down this is Fz
1 by
1 by
root
root
2.
2. So what is the 1 by root 2?
0.707.
0.707, right? So I think this things is the 0.7071 which is given to us. It's the one, right? So 1 minus this value is 0.76115. So 0.76115. So it will be something 0.23
885.
885.
885.
Yeah. So this is clear. This thing is clear for
Yes.
everyone.
Very good, sir.
See, here thing was only these things you have to keep in mind. But basic funda is clear. How will you use the CLT?
Yes, sir.
Okay.
Convert
So we
into
can,
Z.
yeah, we have to convert into the Z. That means standard norm. Yeah, the same thing. Okay, we have converted as x1 is s1, but yeah, procedure is the same. Okay, so answer is 0.23885. It is clear for everyone.
Sir, one
Sir, I
second,
think,
sir.
sir,
Sir, one second. Here,
Yeah.
yeah, expected value of xi square half into 4 equal to 2 and sigma square equal to 8. Why this was found out, sir? What is the use of that?
Okay, I think it's just a written thing. Okay, suppose I find out these things, right? Okay, xi square is okay. So here expected value of xi square is what? Let me write down.
Yeah.
Just find out as
xi
a 2 and
Yes,
variance
sir.
is 8,
2.
right? So
8. Yes,
variance
sir.
of xi square is 8, right?
8.
And
Yes,
I'm
sir.
saying xi square is follow gamma. It was something
Half
half
comma
1 comma 4, right? Okay, these things we have found out. So what I can write down the what? Okay, so tell me What will be the expected value of x1 square plus x100 square?
Okay, 2 into 100, n 200.
Okay.
Yeah, directly itself we can get
Yeah, directly we can, it will be 200, right? What will be the variance of x1 square plus x100 square?
8 into 100.
800, right? So the
Correct,
same
sir.
thing we have computed after these things, right? So
Okay,
in
one
either
step.
way you can proceed. Okay.
Okay, I got it, sir. Thank you
Sir,
very much, sir.
here I think the main thing is to convert normal into gamma. I mean, once
Correct.
squared, it becomes gamma, right? So,
Correct. Correct.
regarding this, there are many points like where x by x plus y becomes beta and x by y becomes Cauchy distribution.
Hmm.
So, there are
Hmm.
many things that were given in a single week's lecture.
Okay.
That is quite difficult to remember all
Yeah,
of
yeah,
them.
I got your point, but don't worry about it will come in. I mean, in exam, okay. But it's a only I can say it's a good if you have remembered the thing. Okay,
Okay.
things are in your mind.
Okay.
But if there are something like that, so we'll provide in the formula sheet. Okay, like see, we know the Chebyshev inequality, Markov inequality, CLT is used most of the time. Okay, but
Yeah,
we
we
have
saw the formula sheet where they have given means and variances of gamma, beta, everything. But
correct, correct.
this one, like normal to gamma and normal to beta, they are
Mhm.
generally not present in formula sheet. In graded assignment, in a question or two, they have given us hints, but
Okay,
we are
so
not sure of the
okay, what
quiz.
happened? Okay, okay, okay. What the thing is basically, Lakshmi. So thing is that in grade assignment, okay, we assume you have done. You have just covered the lecture video, so you have made some notes or you have lecture PPT, right? So you can use the things. You can use the concept from there. But in the exam, during the exam pressure, we forget the things normally. Okay, so that's why we provide the necessary formulas. Okay,
Okay, okay,
in the
okay, sir.
formula sheet. No need to worry about that. Yeah, it's not remember in my mind. But
Okay,
don't expect also. Yeah, formula of expected value expectation will be given. Formula of mean will be given. But
okay,
yeah, the major things will be given to you. Okay,
okay.
like
Yeah, thank you.
inequalities. Every distributions, mean of distributions, PDF, PMF of distributions, CDF distributions, right? So as it's we assuming normally, right? You know the PMF, you know the mean, you know the variance of that distribution, but we normally provide. Okay, no
Okay,
need
sir.
to worry about it. Okay, so we should move to the next question, or is it okay? We should move.
Yes, sir.
Okay. So this question is basically, yeah. Next question is, let x be a random variable having the gamma distribution with parameters your alpha is n and beta is 1 is given to you. Here a hint is given to you, like expected value of x is alpha by beta, variance is alpha by beta square. So it says, using weak law of large numbers, find the value of n such that these things. You have to find out the value of n. But one more thing, it's given as x by n, right? Okay, but by the weak law of large number, what weak law of large number says? What weak law of number says?
X bar minus mu.
Probability that mod value of x bar minus mu greater than some delta less or equal to sigma square by n delta square, right?
Yes, sir.
This thing is says, right? So, but thing is that okay, so here x by n is given to you, right? Not x bar, but it says you have to use the weak law of large number. Okay, so I'm going to give you a hint. So you can let your random variable x, this is the x bar, right? So you can let your x as the sum of n IIDs gamma variable. Are you getting? Not getting?
Yes, sir. Sum of
We'll have to assume it so that instead
Yeah,
of alpha, we have to put n alpha.
yeah. Instead of alpha, you to no, not alpha. Okay. So when your x will follow alpha comma beta here.
alpha by n comma n beta.
Sorry. See, you have to assume your x. You have to assume your x as the x1 plus so on xn, such that your xi is the gamma 1 comma 1. Okay, these things you have to think, but I'm giving you as a hint. Okay, only then okay, if it these things, so your it will be 1 minus 1, right? Are you getting what I'm trying to say here?
Sir, sum of gamma is equal to some gamma, sir.
Then your x will be what? Gamma and alpha, right?
Yes,
So
sir.
n alpha comma beta. So what is it will be? N
N
comma
square.
n comma beta, right? N
Yes,
comma
sir.
1.
Yeah.
Okay.
Beta is
If
1.
if x is follow n comma 1, then are you able to do x by n something? Okay.
We'll try.
So there is rule of words here. Okay. So I'm going to give you 3 minutes. Just try to solve it. Okay. Because your alpha is c n comma 1, right? Alpha it says my x is follow as per the question alpha comma beta, and alpha is n comma 1. So when your x will be n comma 1, when my xi is 1 comma 1, then my x will be n comma 1. Okay, so that's the something accordingly you have to proceed. Question is clear to all of you?
Yes, sir.
Yeah, thank you.
Sir, 2 more minutes, please.
Yeah, sure. So I'm going to give 3 minutes. Okay. So that because I have received only 3 responses out of 35 people. Okay, so just do that, which I have already told you as a hint. Okay, based on those things, just try to solve it. Okay. I'm receiving very less responses. So everyone is able to solve, or it's you are facing difficulty. Okay, so do you need extra time limit for this?
Sir, 1 minute more.
1 more minute? Okay, sure, sir. So let's wait for this. Okay, I will increase the time limit. Okay, so anyone wants some extra time limit, or we can proceed? No one? Hello,
One more
am I
minute.
audible, right? Hello, am I audible to all of you?
Yes, sir, you're audible. I think no one wants any extra time
Okay, okay,
anymore.
okay, 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 okay. Then let me see the responses from your side first. So 10 lakh, 10 lakh, 500, 100, 1, 10 lakh, 10,000. Okay, 10 lakh, 100. Okay, okay, great, great. Okay, so basically, what's WLN? I mean, weak law of large number says, what is the funda behind that? Suppose I have an IID random variable, okay? This is follow some x, okay, with x. So, and let's say mu is expected value of x is mu, and variance of x is the sigma square, okay? So I'm defining as a sample mean, okay? So sample mean is nothing but x1 plus so on xn divided by n, okay? So what the weak law, okay, so what will the expected value of x bar here? Mu. And variance of x bar, what is the sigma square, right?
Sigma square by n minus
By
1.
n.
So what
N,
weak law of
okay.
large number says, modulus value of x bar minus mu, I mean absolute difference between x bar and mu is greater than some delta, should be less or equal to sigma square divided by n delta square, okay? This thing is as per the weak law of large number. Here, as in the question it says x follow gamma, alpha comma beta, and x follow gamma. What is the value of alpha? Alpha is n, beta is 1, right? So this says we have to find out the values of mod of x by n minus 1 greater than 0.01. Not values of this, we have to find the value of n, okay, for these things, okay? As per the weak law of large number, as you can see, and here x is follow gamma n comma 1. So can I let x is the random variable as x1 plus so on xn, okay, where each xi is follow gamma 1 comma 1. Can I say or not?
Yes, sir.
If each xi is gamma 1 comma 1, okay, so what will be the x1 plus so on xn? It should be gamma, as per this,
And
as
comma
per, okay, as per this statement, if x1, xn, IID, gamma, alpha, comma, beta. Then summation of these random variables will be gamma n alpha, comma, beta, right? Okay. So it's a n alpha, comma, beta. So far it is clear. Okay. So n alpha means what? N into 1, comma, beta is 1. So this things, okay, this is nothing but my x, right? So can I say this x is follow n comma 1? This thing is given in the question, right? Is it okay for everyone?
Yes, sir.
Okay, great. So tell me, what is the now? What is the expected value of x?
Alpha by beta.
Mu
N. N.
alpha by beta, that is 1.
What?
Yes. N
N.
And
It is N,
N
sir.
by
N,
1.
N, no, sir. X1, X2, X3 is mu,
I
but
think I
X
ran ahead.
is
yeah,
X1
it will
plus
be
X2
n. Yeah,
plus
it will be n.
X3.
Okay, okay, okay.
N.
Expected value of xi will be 1, right? Expected value of xi will be 1, right? 1 by 1,
Yes,
and
sir.
variance
Yes,
of
sir.
xi will be 1, correct?
Yes,
Yes,
sir.
sir.
What is the variance of x? Again n.
N.
N by 1
First,
square.
yeah, okay. So what is the variance? Alpha by beta square. So it will be 1 n by 1 square, which is again n, right? Now, what we have to find out? We have to find out the mod of x by n minus 1 greater than 0.01 less than 0.01, right? Now, as my x is x1 plus, it will be mod xn divide by n minus 1 greater than 0.01 less than 0.01. Can I write down these things?
Yes, sir.
Okay. Now, forget about this 0.01. What it will be as per my weak law of large number?
Sigma square by n delta square.
Okay. These
Square by
things,
N delta square.
mod of, yeah, correct. So mod of x bar minus mu greater than delta should be less or equal to sigma square divided by n delta square, right? As per the weak
Yes.
law of large number, mod of x bar minus mu greater than delta should be less or equal to sigma square divided by n delta square, right? So as per this, we have to, this is sigma square.
Excuse
What
me,
is n?
sir.
N is n. Delta 0.01 square. Yes, please go ahead.
Sir, sorry to cut you. Can you please explain it again? I'm not getting it.
Okay. These things we have to find out, right? By this,
Yes.
we have to find out the value of n. Correct? Till this step, things are clear.
Sir, not clear.
Okay. So when you are getting difficulty, just ask then. Okay. Okay. So this thing is clear. I have
Yes.
let
Yes.
x as the x1 plus xn, right? And
Yes.
I let xi is the gamma 1 comma 1. If my xi is the gamma 1 comma 1, then summation of NIID random variables will be what? N alpha comma beta,
Yes, sir.
correct? Alpha is 1, beta is 1. So it will be x comma x follow gamma n comma 1. This thing, this information is given already in my question. That's why I let x as the summation of n xi, right?
Sir,
So
but
far
in
it
the
is
question they're asking only about x by n minus
okay.
1.
That's why I let x as the okay. So what is the x? X is gamma n comma 1, right? X is the gamma n comma 1. This thing is given in my question,
Yes,
right?
sir, it's given.
Okay. But if you want to apply the weak law of large number, what you want? You need like this, right? I need these things, right?
Yes, sir.
Okay. So for the simplicity, I let x as the summation of an IID random variables where each xi is gamma 1 comma 1. Okay.
Yes, yes.
So this x is nothing but the function of the this x1 plus x2 plus xn. Okay. So if you will add x1 plus x2 plus xn, so it will be n alpha comma beta, correct?
Yes, sir.
Okay. So it will be x follow gamma n comma 1. So at the end we are getting these things. Means this letting part is okay for me. Okay. So far it is clear.
Yes, sir.
If x follow gamma n comma 1. So what is the expected value of gamma distribution? Alpha by
Beta
beta. So
and
alpha by
V.
beta means n by 1, that is n. Correct? What is the variance of x? Alpha by beta
Beta
square.
square.
So n by 1 square, that is again n. Correct? So these things is
Yes.
given to us by this, with the help of these things, we have to find out the value of n. Since this x, I have to replace with the x1 plus xn. Okay? Because replacing x1 plus xn is the same thing as x. Okay? Because x1 plus xn will follow n comma 1 and my x is following n comma 1. Okay?
Yes, sir.
If my by the vehicle of large number, as I know, probability that modulus value of x bar minus mu greater than delta less or equal to sigma square divided by n delta square. Okay, so what is the okay, so it will be less than sigma square divided by n delta square. So instead of delta, I have 0.01, right?
Yes, sir.
Okay,
Yes.
these things I can do, right?
Yes.
Now tell me. Okay, so what should be the next step?
So we
What is
make
the
it
sigma square?
to 0.01. Like
is
it
n.
sigma square is n. So
Sigma square is the
n.
okay. So it's a
N.
sigma square of x1 plus x2 plus xn. So it will be 1 plus 1 plus 1, right? No.
Sir, it is
No.
sigma square of xi, sir.
Yeah. It's the sigma square of this is not a xi. This sigma square is of
Of
this whole things, right?
say,
We clock.
Sir.
so sigma square will be of the
Each
of
Sir,
the
individual.
xi only, right? Because if we take
x1.
Yeah, one by
if
one,
we
one
if
by
we
one,
take for the whole
one
thing,
by
we
one.
get n and n will get cancelled, so we cannot even solve.
Sorry.
So if it were of the whole thing, we will get
Uh-huh.
n and n will get cancelled.
Yeah, we,
And
we we will get one, right? See, as per the this thing, sigma square is what?
N,
Sigma
sir.
square of
so
this whole things, right? No.
No, sir, it is of individual xi.
it will be of individual, right? Because when we define this, we say
Mhm.
expectation of the IID sample.
Correct. Yeah, correct. So sigma. Okay, so what we will get?
One, sir.
One, right?
Sigma square is equal to n, sir.
See, sigma square is the n. This sigma square is the sigma square of this whole things, right?
Oh,
Sir, no, sir.
okay, sir. Okay, sir.
It has to be of the IID, right? Because if we, for example, assume कि IID का नहीं है, so if it
See,
is not of
okay.
IID, right, then
Okay,
it will
what
be
tell me?
n
What
by
is the
n.
expected value of this thing? Okay, tell me what is the expected value of these things?
Mu.
One.
Yes.
Okay, this will be one.
Yes, sir.
Because see,
Yes, sir. Yes.
because each xi is the gamma
Yes, sir.
1 comma 1, right?
Yes,
Yes,
sir.
sir.
So
Yes, sir.
expected value of xi is what?
One.
1. So it will be n by n, right? It will be 1.
Yes, sir.
What is the variance of x1 plus so on xn by n? 1 by n square. Variance of x1 plus so on variance of xn, right?
Yes.
Yes, sir.
Yes,
So
sir.
1 by n square into this thing will be what? N. So 1 by n we are getting. Okay. Is it okay or not?
Sir, I.
Hmm? See, tell
Sir,
me.
does
What is this sigma square by n? This is me a variance of x bar, right? See, okay. Let me clear this one thing. If
Yes, sir.
what is the weak law of large number says, if x1, x2, xn are IID x, with expected value of x is mu, variance of x is sigma square. Okay. So what is the x bar? X bar will be x1 plus xn divided by n. So what is the expected value of x bar? Is the mu. Correct? Because if you put here, so you will get mu plus mu divided by n, you will get n mu divided by n, you will get mu, right? right or not?
Yes, sir. Right, sir.
What is the variance of x bar is the sigma square by n, right? Okay.
Yes, sir.
So here what we are getting variance of these things as what? Instead of sigma square by n, we are getting as 1 by n, correct?
Yes,
Is it
sir.
okay? Okay.
Yes, yes, sir. Yes, sir.
So what we have mod of x1 plus so on x1 divided by n minus 1 greater than 0.01 less than. So sigma square by n we got instead of sigma square by n we got 1 by n. This is delta square. So far it is okay.
Yes,
Yes,
sir.
sir.
Right
N,
now.
sir. Okay.
Hmm?
Sir, but
So,
the formula says n delta square, no, sir?
So n delta square, right? No. Formula says, see what formula says. Formula says, where is the formula? Yeah,
Sigma square
sigma
by
square
n
by
delta
n
square.
delta square. So what is the sigma square by n? Variance of x bar, right?
Okay, okay. Ah,
Okay,
yeah. Okay, sir,
okay.
correct.
So this is the thing. Okay, so in the question, this equality is given to me as 0.01, correct? See, probability of mod of x minus x by n minus 1 greater than 0.01 is less than 0.01 is given to me, right?
Yes, sir.
And we got by the weak law of large number. This is the my inequality. Are you able to understand, or it's got some
so
confusing?
you
Yes,
have
sir.
said
We have to
that,
equate with 0.01.
excuse me, sir.
Yeah.
So you have said that variance of x bar is sigma square by n. That is totally okay. But how we have got 1 by n? Because
Okay,
we
so
have had
okay. See,
like
see. Try to understand what I'm saying. So variance of x1 plus xn divided by n will be what? 1 by n square variance of x1 plus so on variance of xn, right?
yes,
What we let each
IID.
xi is the gamma 1 comma 1, right?
Yes.
So variance of xi is what? 1.
Yes.
Okay. So variance of xi is 1. So you will add here 1 plus 1 plus 1 till n times. So you will get n.
Yes.
So n divided by n square, what I will get? 1 by n, right?
Yes.
Okay. So now
Yes.
this should be less than these things, correct? Correct or not? See, what is the given in the question? What we is given? This thing, with the help of this, we have to find out the value of n, right? With the help of weak law of large number, okay, let me raise these things. With the help of weak law of large
See,
number, I
just
got this thing, right?
so just
Correct?
one question. Maybe I think because in the formula we have sigma square by n delta square. So you are calculating when we are saying variance of this
Hmm.
uh, x bar, we are
Uh,
calculating this directly sigma square by n, that entity we are calculating, right? So because
hmm.
if we were to calculate just sigma square, we'll get 1, and then we put it in the formula, we'll get the same result. But when we do it this way, we are calculating sigma square by n, that combined quantity. That is why we are getting 1 by n, and we are substituting in the formula. That is what is happening, right?
Yeah, it's a sigma square by n is what? This is nothing but variance of okay, by weak law of large number, variance of this quantity, right? Variance of this x bar, right? This sigma square by n is what? Variance of x bar, right?
Yes, sir.
Okay. So we have to find out in this case variance of x1 plus xn divided by n. So we
Hmm.
find we got variance of this whole quantity as 1 by n.
Hmm.
Okay. Is it okay for everyone or not? I mean, I'm not getting
So
the
for
conversation.
the last part of the weak law of large numbers,
It is
like we are
okay now.
getting that 1 by n, we will
Hmm.
equate it to 0.01, then we'll get the value of n.
Correct, correct. That's the another thing. Yes,
Okay.
Sukanya and Prasant raised hand. Yes, please.
So I want to ask one thing.
Hmm.
Like while the one we were saying of scaling of the right random variable. X
Hmm.
is a sum of gamma, which again is a gamma variable, right?
Correct,
If
correct,
we are
correct.
of n gamma variables, it is. Now, if we
Hmm.
divide it by n,
Hmm.
what will happen? Will it follow 1 by n beta?
1 by n beta.
Beta, like it's gamma n alpha beta, right? In
Hmm.
general. So
Hmm.
if we divide the random variable by n,
Hmm.
what will be the distribution of that gamma? Sorry,
No,
didn't you
we
get
know
me?
the summation of random summation of the gammas, right?
No, no. I'm
Hmm.
asking because if it will follow simply alpha beta, like sum is 1
Okay,
gamma is alpha
okay, okay.
beta, then the sum is n alpha beta, right?
Correct, correct, correct.
Okay. Now, if I'm dividing it by n, I'm dividing the summated random variable by
So
n.
just okay. So just find out this. Just find out the expected value of x and
Huh.
variance of these things.
So it
That's
will
all.
be simply one alpha beta, right? Again, because
No,
when
as
I
per
divide by n,
okay, okay. So what we have? It's nothing but we have these things, right?
huh,
So each exercise is follow gamma 1 comma 1, right?
huh,
So
yes,
what is the expected value of x1? It will be 1 plus 1 plus so on 1 divided by n, right? So we
huh,
got n by n, we got again 1, right?
1. Okay.
So
And
what?
we'll get a corresponding variance also.
Correct, correct.
I want to ask because since expectation is 1,
Hmm.
um, like this means, okay, can you find the variance also, sir? I
Okay.
wanted to ask
Okay.
because
Okay.
if
So what it
this,
will be? 1 by n square
huh,
variance of x1
that is again
plus so
1.
on variance of
It will
xn.
be 1
So
by
what
n.
will be the variance of xi here? Alpha by beta square. That means 1 by 1 square. That is 1, right?
Huh. So it will
Correct.
be
Yeah.
1, right, sir?
1 by n.
So it will
1
be
by n.
n square. So I will get n by n square. It will be 1 by n, right?
So, okay. Now,
Hmm.
if when gamma follows
Uh-huh.
1 by n, when alpha is
Okay.
equal to 1, it is an exponential distribution, right?
It is exponential distribution. Okay. So you are
For
saying
gamma, alpha,
x by n
beta,
is follow exponential distribution.
in this case, won't it follow exponential? Then this process will become easier, right?
Okay. Okay. So we need to check. We need to check. So we what you can
Ask
do.
me.
Okay, so no, I need to check. I'm
Huh,
not sure whether it's follow exponential or not. So what you can do, just put the value of this x by n, which is 1 comma 1 by n, right? Put the
hmm,
value of alpha and beta in the PDF of gamma. Okay.
okay.
If you are finding the value like this, lambda response minus lambda x, something like that, or lambda x by n, something like that, then it will be exponential. Are you getting my point? Okay. So just put the
Sorry.
value of alpha and beta in the PDF of the gamma distribution.
Okay.
Okay. Okay. So that's the different thing.
I'll
So
try
what?
and ask you, sir. One
Yeah,
minute.
yeah, sure. You can put on the discourse and let me raise these things. Okay. So this thing is clear. WLLN and inequality which are given to
Sir,
us. Yes.
sir, does the
Yeah, yeah. Please go ahead.
Sir,
Hmm.
sir, here sigma square is variance of each xi, sir.
Each exercise, yes.
It is 1.
Which is one. Okay.
Okay, sir.
Yeah, we can directly say that instead of finding out, right? Sigma square of variance of each xi, which is 1. Okay. So these things we find out by the weak law of large number, and this thing is given to us. So can I write down this thing as 1 by n 0.0 sigma square is less than 0.01? Correct. So what I will get? I will get uh, 1 by 0.01 cube less than n, right? Correct.
Yes, so
It will be n greater than 1 upon 0.01 raised power cube. So what it will be? I can what I can write down these things. What will be 0.01?
Point five zeros and 1.
Sorry?
Point five zeros, 1. That will be 0.01 cubes, sir.
10 to power minus
0.000001.
6.
Into power
10 to
minus.
power minus
Correct. Okay,
6.
so you can convert it, it as 1 by 100 also, right? Are you, okay, so if 0.01, what I can write down the 1 by 100? Correct?
100 cube.
So 1 by write down the 10 is square, right? Correct?
10 to the power of 6.
Okay, so it's a whole cube, it's a whole cube, it's a whole cube. So I will get 1 upon 10 raised power 6. So 1 upon, this will be 1 upon 10 raised power 6. So I will get n should be greater than equal to 10 raised power 6. That is something 10 lakhs, right? So n should be at least 10 lakh. Okay, so is it clear for everyone?
Yes, sir.
Okay, so
Sir,
only
does
thing is you have to, I mean, there is something that trick, that this trick is there. You have to identify this one. If you identified this one, then you can easily use the weak law of large number. Okay. Yes, Devans.
Sir, does the alpha parameter depict the
Mhm.
number of IID samples in a particular distribution there?
Number of IID parameters? No, I
The,
don't think it's a number. Okay, it's just
because
something. If you read detail in gamma distribution, it's something scale parameter, shape parameter. Okay,
yes, sir. So
that's
because
not.
hmm,
Hmm? Hmm? Yeah,
because
yeah. Please
in
go
the
ahead.
question the alpha was given as n, and here also the total number of IID samples were n. So I just suspected whether alpha depicts
Hmm.
the total number of IID samples given.
No, see. Okay, I don't think, because if you are saying like this, then its here alpha is 50. Okay, but it's not 50 random variables, right?
Okay. Yes, sir.
Okay, don't generalize is like that. Okay, something is scale parameter, shape parameter. So that's not in the depth. We have to not go in that depth. Okay, so it's clear so far, everyone. Okay, the only confusion part was this. Okay, so be clear with this, right? With the weak law of large numbers. So it's a, I can directly put the value of sigma square also, or else what I can do, I can put the variance of this thing. So at the end I will get 1 by n. Okay, is it clear for everyone?
Yes, sir.
Sure, we can move.
Yes, sir.
Yes, sir. Yes, sir. Please, sir.
Sir, here we need not calculate variance of x.
No. See. What we, okay? What is the variance of x? This is, these things we are doing, right?
Yes,
Try
sir.
to understand the inequality. What say we say inequality? Sorry, weak law of large numbers is. This is less or equal to sigma square divided by n delta square, right? So what is the sigma square basically? Variance of each exercise,
Yes, sir.
correct? Or else I can say this sigma square by n is the variance of this x bar. Both are same, correct?
Yes, sir.
Okay, so be clear with it. Either I can see in this question, either I can put the value of sigma square directly, which is 1, since each variance of each xi is 1, or else I can find out the variance of x1 plus xn divided by n. At the end I will get again 1 by n. Okay, so by either method you will get the same values. Okay, it will be 10 lakh something. Okay, it is clear for everyone.
Yes, sir.
Okay, I'm not getting that much energy in yes.
Sir, I also like, did it with this second method only. Like sigma square, I calculated like alpha by beta square, and then I took n value like normal
Okay,
n
okay,
in the
okay.
formula.
Okay, so here question is the same, but here you have to use the CLT. Okay, not weak law of large number. Okay, so what is the difference for using the CLT and weak law of large number? So just go with like that. You can let your x as x1 plus xn. Okay, and those exercise will be gamma 1 comma 1. Okay, and then try to convert this x by n in the form of standard normal variate. Okay, so I'm going to give 3 minutes for this one. Question is clear for everyone?
Same question, sir, but different method.
Yeah, question is same, but only difference is you have to use the CLT. So for using the CLT, so what you have to do? You have to find out the expected value of x bar, which is x by n, and variance of x by n, and then just use the CLT, and then you will get this inequality. Question is clear, right, for everyone? Hello, am I audible to all of you?
Yes, sir, it is clear.
Yes,
Yeah.
yes.
Oh, okay, great, great. Okay, I think this weekend mock will be released. Okay, so be ready for that.
So for some reason, I'm getting confused on how to approach. I don't know, but Tani, all right.
Okay, no, so we'll see. Okay, just be clear with for the. Okay, so I have received only one response. So let me give 3 minutes. Okay, so be clear with while you are using the CLT, just try to convert your random variable as standard normal. Okay, means you have to subtract. Let's say that random variable is x, so you have to do x minus expected value of x divide by standard deviation of x. Okay,
Sir, I'm
so
getting
just
confused because of the mods.
okay, so if it's mod, then suppose I'm saying mod of x is greater than 2. So I can write down the, let's say, so this mod I can change like, okay, so suppose I'm saying mod of x is less or equal to 2. So what I can get?
Two inequalities, sir.
Two inequalities, right? So like that, you can proceed. Suppose I'm saying mod of x is greater than 2 means what? X is greater than 2 and x is greater than minus 2 or less than minus 2. What will be?
Sir,
Less than minus 2, right? Okay, do you need extra time limit or is it okay?
Yes, sir.
3 minutes, 1 minute,
2 minutes, sir.
2 minutes. Let me give them 3 minutes. I think question is getting difficult for you. Because I have received only 7 responses so far.
Sir, it is getting difficult for me.
Okay, no
Sir,
issues.
I need
We'll
more
see.
time.
How much? 1 minute?
Yes, sir.
Okay, let's wait this 30, 34 seconds, 35 seconds. After that, I will increase 1 more minute. After that, we'll see the solution. We'll discuss the solution, okay? Because I think it's already is going to 8. I think some of you have to both join the match 2, right? Match 2 session or... Okay, so we'll continue the session. Those who want to stay here, they can stay, else they can go. They can watch on the YouTube it later. Okay, I think there are 2 more questions. That's all. So here, okay. So let me see the responses from your sides. So 4 people are saying option B, 2 are saying option A, and 2 are saying option D. Okay, so let's see. We have to find the value of n such that this. Okay, so question is the same. Only difference is we have to do with the help of CLT, right? Not with the weak law of large number. Okay, so what we had done in the previous, we have done like this, right? And by each xi was following, follow gamma 1 comma 1, right? Right. Then my x will follow gamma n comma 1, right? This was the thing, right? Now, for using the CLT, what we have to do? We have to subtract the mean and divide by the standard deviation, right?
Yes, sir.
What we can do, what we can do from here. So let's say, uh, what is the expected value of x by n? We have to find out the right, because we have to subtract the mean. We have to divide by the standard deviation, right? So what is the expected value of x by n will be, right?
1.
So expected value of x1 plus so on, yeah, 1. It will be expected value of xn divided by n. So what is the expectation of each xi here?
1.
Alpha by beta. So 1 by 1 is 1. Okay. So it will be 1 plus, correct. So 1 divided by n. So n times 1 divided by it's n by n, which is 1. So we got expected value of x by n as 1. Okay. Now, what is the variance of x by n? That means 1 by n square variance of x, correct? So 1 by n square, what is x? X is x1 plus x n, right? So it will be n square. So it will be variance of x1, since all the random variables are independent. So it will be variance of xn. Okay. So what is the variance of each xi from here? Alpha
1.
by beta square, right? So again 1. Great. So we are getting 1 plus 1 plus so on 1 divide by n square. So it's a n by n square. It's a 1 by n, right? So it's clear so far. Expected value of x by n 1 by n. Variance of x by n is the 1 by n, right? So in the question it's given x by n minus 1 greater than 0.01. Okay. So let's compute this one first. So what I will get? Okay. So what I can do? X by n minus expected value of x by n, right? Divide
Yes.
by standard deviation of x by n, right? These things I can do or not?
Yes, sir.
Right? So this should be
Yes,
something
yes, sir.
0.01. Okay, let's
The
write
minus
this.
1 is there, no, sir? What happens to that minus 1?
One second, one second, one second. Okay, okay. So what we can do? Sorry. Let me add a page here. Okay, great. Okay, now. Okay, so let's do here. Don't go like this. So what I can do? So x, I can write down the each x like this, right? Correct?
Correct.
Right? So what it will be? This is xn minus n, correct? Divided by n mod. Can I do or not? See,
Yes,
just
sir.
transformation, right? This thing so far it is clear.
Okay, sir.
Okay. Now what should be the next step?
So now we have to add, subtract expected value of x.
So it's not already
Divide by.
subtracted the expected value. Okay.
No, this one is expected value of.
Okay. One second.
Uh,
One second. One second. One second. One second. Okay. One second. Let me clear these things. Okay. Forget about these things. Let me do. Let me add a page here. Okay. So I said x was x1 plus x2 plus xn, right? I said like this.
yes,
Okay.
sir.
And each exercise was gamma 1 comma 1. Okay. These
Sir.
things we had done, right? So what will be this summation?
Gamma n comma 1.
This will be correct. This will be nothing but gamma n comma 1, right?
Yes, sir.
Okay. So expected value of x1 plus so on xn is what here? N?
Correct, sir. Sir,
N
that
by 1, this is
okay.
n, right? Now let's do like this. What is the variance of x1 plus so on xn?
Then
N by 1.
N by
1 square. N by 1 square equal to n.
again n, right?
yes, sir.
Correct? Now
Yes, sir.
n by 1 square. Okay. One second. I think I'm making some mistake here. Okay, so expected value of this. Just a minute. So if this is okay, so this is the expected value of this whole things, right? Correct?
By n now, sir.
Sorry?
That is x by n which is given in the question, x by n.
X by n is the given in the question, so it's x by n minus 1. So it's x1 plus so on xn. Okay. So it's sigma. Okay, yeah. Okay. Sorry. Okay. See, this is the x by n minus 1. Okay. This
Yes, sir.
okay. We are getting just a second. So this is mod of x minus x by n minus 1 greater than 0.01, right? This is given to us, and we have found out the what is the expected value of x by n? 1.
1.
Okay. So expected value of x by n is 1 is given to me, right? The only thing we have to do for making the standard normal variate, what we have to do? We have to divide. See what we have to do? X by n minus expected value of x by n divide by standard deviation of x by n, right?
Okay.
But x by n minus expected value of x by n is already given. What we have to do? We have to just divide by the standard deviation of x by n, right?
Yes,
For
sir.
making the standard
Yes,
normal
sir.
value. Correct? See, this is the expected value of x by n from here, right? So x by n minus 1 is given to me. For making the standard normal variate, what we have to do? We have to do divide by the standard deviation of x by n, right?
Yes, sir.
So what is the standard
But
deviation of x by n?
x by n minus 1 should be taken as x by n minus mu, minus expected value. Because here expected is 1, so we are not subtracting in
Yeah,
regular
we are not
manner.
subtracting the expected value. It's already given. Okay.
Okay. Now we got it, sir.
Okay. So what is the standard deviation of x by n?
1 by
1 by
root
n.
n.
1 by n. Yeah. See, variance of x by n is the 1 by n, right? So standard deviation of x by n will be what?
1 by root
1 by
n.
root 1 by root n. So
By
we have to
root n.
divide by these things, right? So if you divide by these things, what I will get? Let's say this is x by n minus 1. I will get root n.
Greater than 0.01 divided by root n.
Greater than
0.01 divided by root n.
Sir, we will divide by 1 by root n.
Yeah.
Divide by root n, sir.
No, sir. We'll divide it by 1 by root n. So it
1
will
by
get
root n.
multiplied. Yeah, it will get multiplied in 0.01.
You have only divided by root n.
So this side, left hand side, we divided by root n.
Okay, these things, right? These things, right?
Yeah.
Yes,
Okay.
sir. Sir.
No. Yeah.
1 by root n. Okay, correct.
What is this? This is nothing but my z, mod of z. Correct?
Yes, sir. Mod of z.
See, random variable minus expected value divided by standard deviation of that things,
Yes,
right?
sir.
So mod of z, right? So this will be greater than square root of n 0.01.
Yes,
Correct? Now, so far it is clear. It is okay for everyone.
Yes, sir.
Yes, sir. Yes, sir. Up to here, okay, sir.
Okay, up to here it is okay. Suppose, okay, so what will be this inequality?
Sir, 1 by root n cos है.
See, 1 by root n is nothing but standard deviation of x by n. Okay.
Oh, okay, sir.
Okay. Now, so what it will be? Okay, so this is nothing but the standard normal variate, right? See, what I can write down these things. Anybody?
Yes,
Yeah.
sir. Probability of z greater
See,
than root n
this
0.
means what? This means what? Probability of z is greater than square root of n 0.01, or z is lesser equal
Lesser.
to minus
Minus
this things, right?
0.01. Yeah.
Right? The meaning of this thing is
Yes,
this
sir.
one, right? Since this is just a standard normal variable, as per the standard normal variate, suppose this is the standard normal variable, means mean is 0, right? Suppose this is, I'm saying this is minus 2, this is 2. So probability z is greater than 2, lesser equal to 2 is same,
Yes, sir.
right? This is same as probability z is lesser equal to minus 2 by the symmetricity. Is it okay for everyone?
Yes, sir.
Okay, is it okay for
Yes,
everyone?
sir.
Okay.
Sir, actually, that Z is greater
Yeah, z is the
less
standard
than.
normal.
No, for that both side it will come, no, sir. Delta.
No, I will come
Okay.
to that point. I'm just computing the this part. Okay. I will come to this 0.01 also.
Okay, okay, sir. Okay, sorry,
Okay.
sir.
No need to worry about it. I'm just trying to explain the how will you use the CLT. So basic fund of his CLT is I have to make it as standard normal, right? So here I have make it as standard normal. If I'm writing mod of z greater than root n 0.01, that means what? Z is greater than root n 0.01, or z is lesser equal to minus square root of n 0.01. This till this is step it is clear.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
In the
Because of
normal
mod,
distribution,
because of mod
yeah,
is there.
because of the mod,
We are splitting
yeah,
into two.
two
Okay, sir.
parts.
Now I got it, sir. Yes,
Okay.
correct.
So see, in the case of normal distribution, due to symmetricity, can I say probability of z is, suppose this is 2. I'm just taking it as in example. Probability of z is greater or equal to 2. It is same as the probability of z is less or equal to minus 2.
Correct, sir. So you can multiply it by two times.
So this means,
Same
yeah, this means
probability.
what?
Two
Correct,
times
correct.
XZ.
This means, so it will be what?
Two
2
times
times
XZ of
probability of
minus
z.
Two times.
0.
Just take the positive one. Okay. So far it is clear. Can I write this or not?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir. We can write,
Because
sir.
okay, okay. Let me add one more step so that it will be clear for you. So this means what? Probability z is greater than square root of n 0.01. It's also probability z is lesser equal to minus square root of n 0.01, right? Since this things is the same as these things, right? So I can write on the probability z is greater than square root of n 0.01, okay, plus probability z is greater than square root of n 0.01, right or not? So it will be 2 times of probability z is greater than square root of n 0.01. So far it is okay to everyone. Hello.
Yes, sir.
Yes, sir.
Is it okay? Okay. So this whole things, as I have computed only this thing, this whole thing should be less than 0.01 as per the question, right?
Yes,
Correct.
sir. Correct. Correct.
So
Correct.
this thing should be less than 0.01. Okay. That means what? Probability z is greater than square root of n 0.01 less than 0.01 divided by 2. Correct.
Okay.
Okay. If this thing is greater than, so I can write down that this thing's 1 minus probability z is less or equal to square root of n 0.01 less than, what is the 0.01 divided by 2? Let's 0.01 divided by 2 for now. This thing is clear so far?
Yes, sir.
Okay. So what you can write down here? Can I say 1 minus 0.01 divided by 2 is less than probability of z is less than square root of n 0.01? Just transformation. Correct? Correct or not?
Yes, sir.
So what is this?
Yes,
This is
sir.
nothing but 0.995.
Yes, sir.
Okay, this is going to some lengthy thing, but yeah, you need to care about the just a concept. Okay, so this is greater than 0.995. Okay. Okay, so in the question, as you can see, 0.995 is what? FZ 2.58. Correct?
Yeah, correct.
So
Yes, sir.
probability if Z is greater than square root of n 0.01, this is nothing but FZ. Okay, not this is okay. One second, one second. If I'm writing down this probability, okay, so it's a FZ 2.58, right? Correct? No.
Sir,
Sir,
last
I
time,
think,
sir,
I
how
think,
this
okay,
point
okay,
zero one is equal to 2.58,
okay,
right? We
okay.
can directly.
This is the less or equal to, right?
that's what.
Yes, sir.
Yeah. Now, so this thing I can write down the fz of square root of n 0.01, right? So far it is clear for everyone. Hello, is it okay?
Sir, yes, sir. Yes, sir.
Okay. So what I can write down from here, square root of 0.01 is greater than 2.58.
Correct. Then root of
What
n.
I can say, yeah. So I can say square root of n is greater than 2.58 divided by 0.01, right? If you multiply it by 100, you will get square root of n is greater than 258, right? So what will be n? N should be greater than 258 square. I mean square of the, if you square both sides, you will get these things, right? Are you getting my point, or I think because I'm not able to
Yeah,
explain.
correct, sir.
Okay. So
Sir, how did you remove that FZ, sir?
which
Both
abject?
side FZ are there, no?
Yeah, both sides the abject is there,
Yes,
right?
sir.
See, 0.995 is what? Is given in the question. 0.995 means abject 2.58, right?
Yes, sir.
So abject 2.58. We find the left side abject square root of n 0.01 abject 2.58. So can I say this thing is same as this thing? Only then this will inequality will be greater, right?
Yes, sir.
Okay. The same thing is square root of n should be square root of n multiplied by 0.01 should be greater than 2.58, and then like that. Okay. So you will compute 258 square, you will get your answer and should be greater than that value. Okay. Is it clear for everyone?
Yes, sir.
Okay. So the same thing we have done here. Okay. So let's move to the next question. It's again it's a nice one. Okay.
Sir,
So I think it's a simple. So I'm going to give 3 minutes for this one, I think.
sir,
Yeah,
how
please go
are
ahead.
we getting different ends, sir?
Different.
Ends for the previous question.
Yeah, that's why. Okay, that's the use of CLT and weak law of large number, right? In weak law of large number, we are finding a bound, right?
Yes,
Correct.
sir.
So what why is the name is weak law of large number? It's a weak. It's giving you a weak bound, right? And in
Yes, sir.
CLT, we are approximating the probability. So with the help of CLT, we got the good result. Since we, with the help of weak law of large number, what we got, n should be greater or equal to
10
10
lakhs.
lakh, right?
Yes, sir.
But CLT says no, your n should be greater or equal to 258 square. So that means CLT gives you approximate value, means, and your n will be approximately close to 258 square. That's the meaning. Okay.
Yes, sir.
Okay, so for this, it's a 3 minute. So I think it's a simple one, okay? Because X bar is something you have to find out. So you can define your X and accordingly you can proceed.
Sir, here we can use weak law of large numbers.
Yeah, hello. See, what's the given in the option? It's given in the in form of a capital FZ, right? So when you will get in terms of FZ, that means you have to transform the things in terms of standard normal variate. Okay. And when you will get in form of the standard normal, once you will transform it as the, I mean, once you will use the central limit theorem. Okay. So just use the central limit theorem. Hello. So question is clear to all of you?
Yes, sir.
Yes, sir.
Okay, okay. Okay, so any one of you need extra time?
Sir, yes, extra time needed.
3 minutes. Let me give 1 minute. After that, if you will extend the time limit, okay? Okay, so extra time limit. Anybody received only 7 responses? Anybody?
Sir, 1 minute, sir.
Okay, 1 minute. Okay, so let me give 1 minute. So, do you need extra time limit? Anybody? Or else we can proceed. No one?
No, sir.
So if you are not okay, 7 people are saying option A and 2 people are. If you will give a response like this, yeah, yes and no. So accordingly, I can wait. Right? Else, I will give some time limit, or I will solve the questions and will. So it's not like that. So it's something sessions for you. So
Sir, I think I'm
just
getting the
to give you,
approach,
I
but it
want
is taking time to solve. And if you want to
things.
give
So you
answer,
can
you can
say
give.
I want extra time limit and like that. Okay. So let's see the solution first. Okay. So it says speed of vehicles on a particular road are normally distributed with mean 25 and standard deviation 3 mph, right? So what's your x? X can be what? What will be my x? I can find x as the random variation which denote speed of vehicles on per road, right? This can be my x, right? Is this x is for mean? What was the mean? 25 and standard is 3. So
Sir, your
with
voice
two
is
variance,
breaking.
right? Hello?
Yes, sir, it is for me as well. I thought my internet connection is.
Okay, so now is it okay? Hello?
Sir, your
No,
voice is
still breaking. Yeah.
Hello? Am I audible?
Yes, sir. Now
Yes,
it's
sir, you
clear.
are.
Okay, great. Okay, so let me share my screen. Just a minute. Why is this? I think there is some network problem from my end. Hello. Now am I audible?
Yes, sir.
Yes, sir.
Okay, okay. Yeah, I think actually there is some weather problem in my area. So due to that, I think there might be some network issue. Okay, so now my screen is visible to all of you.
No. Yes, sir.
Now, now it's visible.
Yes,
Yes,
sir.
sir.
Yes, sir. Now
Okay.
it is visible.
Okay. Oh, yeah, great. So x is speed of vehicles on a particular road, right? And it says this follow normally with mean 25 amperes and the standard deviation is 3 amperes, right? So mean is 25, so it's a mu and it should be sigma square, right? So sigma is given to me 3, so sigma square will be 9, right? So far
Yes,
it is
sir.
clear?
Yes, sir.
Yes, sir.
Okay.
This we have
Now,
identified.
yeah. So question says probability that mean speed x bar of 30 randomly selected vehicles is between 24 and 27. So it says we have to find the probability that mean of 30 vehicles should be lies between 24 and 27. These things we have to find out, right? Correct?
Yes, sir.
Yes,
Now,
sir.
tell me if x is follow n, so x bar is says what? About 30 random variables, right? X1 plus x2 plus x30 divided by 30, right? So what will be the mean of this thing? Expected value of x bar?
25 into 30 by 30.
Correct. So this will be x30 divided by 30. It will be, see, all are IID. So 25 times 30 in divided by 30. So I got 25, right?
Yes, sir.
So mean of this is 25, comma. What is the variance of x bar? Variance of x1 plus so on x30 divided by 30. So I will get 1 by 30 square, that means 900 into variance of x1 plus so on variance of x30, right? So what are the
Yes.
variance for each xi? 9. So
9.
30 times divided by 900. So it will be 3 by 10,
3 by 10.
correct?
Yes, sir.
3 by 10 is the variance, right? If I'm not wrong.
Yes, sir. Yes, sir. 9, 900, 30 by 100, 3 by 10.
Yeah, it will be 100. Yeah, 3 by 10 is right, right? So far it is clear.
Okay,
That
sir.
means variance is 3 by 10. Okay. See, it's a simple things. If x is follow normal mu comma sigma square, then what is the x bar is the normal mu comma sigma square by n, right? It's a direct, right? So it's a normal mu is 25, sigma square is 9, 9 by 30. Okay. These things we have computed separately.
Sir, 9 by 30 is variance.
9 by 30 is the variance. That means 3 by 10, right?
Yes, sir. Yes.
It is clear. Okay. Clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we have to
You
find
can.
out the variance. We have to find out this inequality, right? What I can do 24. Okay. So I have to convert these things by the, I can do these things or not.
Okay, both
Correct?
sides. Okay, correct, sir.
Correct. To convert, to make it as a standard normal, right? So what it will be, we have to subtract the expected value of x bar. So what is the expected value of x bar
25.
is 25, right?
25.
Divide by standard deviation of x bar is
3 by 10.
square root of 3 by 10, correct? Now this should be 27 minus expected value of x bar is 25 divided by 3 by root 10, right? Oh, sorry, square root of 3 by 10, right? So far it is clear.
Yes, sir. So middle
What it
one
will
is
be, it
equal
will be
to Z.
minus 1. Correct,
Root
correct,
30.
good.
You
So it
can
will be
change that
z
as Z.
less, it will be not minus 2, it will be 2 divided by square root of 3 by 10, right?
Okay.
Correct. So
Yes, sir.
what will be the next step?
So fz of minus 1 by root 3 by 10, this will be the probability.
Right, this one, right?
Yes, sir.
This is the z. This is the 2 times of root, right? Right. Okay. These things. See, in
Yes,
the
sir.
denominator it's a 3 by 10. 10 will be upper set, right? So what is the square root of this 10 by 3? Anybody? What is the value? One. What is this value? Anybody can compute?
Minus 1.8.
Sir, 1.825.
So
1.825.
1.825 less than z, less than what about this? 2 times
2 into
1.825, right?
yes, sir.
It's
3.65.
something 3.65. Great. So as we know, if probability, you know these things, right? So I can write down these things as probability x is less or equal to b minus probability of x is less or equal to a, which is nothing but fxb minus fx of a, right? Correct.
Yes, sir. Yes, sir.
Yes,
So
sir.
these things I can write down the probability z is less or equal to 3.65 minus probability z is less or equal to minus 1.825, right? So this is nothing but capital FZ
Yes, sir.
3.65
3.65
minus capital
minus
FZ minus
capital Z
1.825.
1.825.
Okay, I think this should be the answer. Let me see. Yeah, the first option. Okay. So key thing is there by for using the CLT, what you have to do, you have to just make that as a standard normal variable. For making them, you have to subtract the expected value of that random variable and divide by standard deviation of that random variable. Okay.
Yes, sir. I think
This was
with this background, we can work out the graded.
correct. So
We will try, sir.
yeah. So this question is clear for everyone.
Yeah, yes, sir.
Yes, sir.
Sir, this will
Okay.
be
So
tomorrow. It will come in the
portal. Yeah.
YouTube. Yeah, portal. Okay, okay,
Yeah.
sir.
In YouTube also, in the slides will be uploaded on the portal also. Okay.
Okay, okay,
YouTube,
sir.
the video is available even now.
Yeah. So where you to find the fourth moment of normal 0, 9 distribution. So can you tell me how will you proceed for the moment? You have to use the MGF, right?
Yes.
So I'm going to give you a hint here. Anyone who can tell me what is the MGF of normal 0, sigma square? Anyone?
Sir, 1 plus
E raised to
No.
lambda.
Yeah. E raised power
square by
lambda
2.
square sigma square by 2. So this is something it should be by heart, right? It should be right.
5
Suppose I
star.
ask MGF of normal 0, sigma square in the midnight to you, then you can directly say it's a e raised power lambda square sigma square by 2. So just uh, keep in your mind, so it will help you. Okay, so MGF of 0, sigma square is nothing but e raised power lambda square sigma square by 2. With the help of this, you have to find the fourth moment of normal 0, 9. So just use this procedure and you do it. Okay. Question is clear for everyone?
Sir,
Hmm?
so we should use MGF expansion, sir. In this question.
Correct. Because if you expand, so I'm telling you, see what is the okay. So you know how will you find the first moment, second moment from the MGF?
Yes, sir.
Okay. So suppose I'm saying kth moment, then it should be the coefficient of lambda raised power k divided by k factorial in the expansion formula, right? So here question is about fourth moment. So it should be coefficient of lambda raised power 4 divided by 4 factorial. So you have to expand that one e raised power lambda square into sigma square by 2. Okay. Are you getting my point?
Yes.
240. Sorry, sorry. In the lecture video, sir had up to fourth moment, sir itself has done, sir, for 0 comma sigma square.
Okay, okay. So
That sigma
if you
square we have
remember,
to
then you
put.
can directly do, right?
Yes, sir.
Yeah,
Afternoon
but
only I was studying that.
okay, okay, okay. So, but best thing is you need to understand the concept. I mean, why we are you doing the things? I mean, suppose instead of normal, there is some another distribution, right? Then you have to do
Yes, sir.
expansion again.
Yes, sir. This
Yeah.
8.1 activity question fully only this one only, sir. Only moments only we
Based
are
on the
finding.
moment.
Yeah,
Okay,
based on
okay,
moment only. Everything, all the 4 or 5 questions what we are having,
okay,
different
okay.
different
So,
types.
were you able to solve that?
Yes, sir. Yes, sir. I was able to solve. 8.1
Okay.
was I was able to do. 8.2 is 0. I could not do not even one. Today, maybe after this session, I'll be able to do, sir.
Yeah, yeah, just try after the session. Okay, if you are facing difficulty, just you can put on the discourse and all things. We are there. So
Yes, sir.
one
Yes,
minute,
sir.
I'm going to extend the time limit. Okay. So in the discourse, you can push post and I mean you can post your calculation also. Yeah, I have done till this point, and I'm not getting the answer, or I'm getting the wrong answer. So where I'm making the mistake, like that. Okay. So you can tag
Yes, sir.
to me, tag to Srikant sir, tag Avinash, Hers, anybody, and we'll solve it. Okay.
Okay.
After okay, okay. So just key idea is CLT. If it's anything, so it's approximate the probability. First thing. Second thing, to use the CLT, you have to make that random variable as a standard normal variate. Okay. Whatever the expression is, summation, it's a mean, it's a deviation, whatever. Just you to find out the expected value of that one, variance of that one, and accordingly proceed.
Sir, after this, I have one question, sir. I'll wait, sir.
Okay, okay. Related to activity.
Related to this only, sir.
Which one? This normal.
This, yes, sir. Moments.
Okay,
It
okay.
is
No, no,
actually
no
a
problem.
question, sir. Quiz 2, quiz 2, March 22.
Okay, 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 okay. No problem, no problem.
Okay, sir. Thank you.
Okay, so any one of you want extra time limit, or should we proceed?
Sir, 30 seconds.
Okay, okay, okay. Great. Okay, so let me see the responses. So 243, 243, all people are saying 243. Okay, great. I think you got for the this is the first time I see the same answer. Okay, so what is the moment MGF? It is nothing but mx lambda, right? So it's expected value of e raised power lambda x, right? So what is the e raised power x? That means what? Expected value of it's a, you know what is the e raised power x? 1
1 plus
plus x square by
x
2
square.
factorial, x cube by 3 factorial, and so on, right? So
Yes,
it
sir.
will be e raised power lambda x means 1 plus lambda times of x plus
Lambda
lambda square
square.
by 2 factorial plus lambda cube x cube divided by 3 factorial plus so on, like that. Okay, let's say we need fourth moment, so I'm writing the fourth one also, so on, right? So what it will be, I can write down the 1 plus lambda times of expected value of x, correct? Lambda square by 2 factorial is expected value of x square
X
plus
square.
lambda cube by 3 factorial expected value of x cube plus lambda by 4 divided by 4 factorial expected value of x 4 plus so on, right? So in the moment generating function, basically coefficient of lambda, this is first moment, right? First moment means mean. So coefficient of lambda square by 2 factorial, it gives you the second moment, right? Coefficient of lambda cube by 3 factorial gives you the third moment. It generates the moment. That's why name is moment generating function. So coefficient of lambda raised to power 4 divided by 4 factorial is the fourth moment. Okay. So in general, I can say coefficient of lambda raised to power k divided by k factorial is the kth moment. What is this? This is expected value of x raised to power k. Okay. Now, as we know, MGF of normal 0 comma sigma square is what? E raised to power
E
lambda
power
square sigma.
lambda square sigma square by 2.
Okay. Let's say here x or let's say y or let's say x is okay normal 0 comma sigma square. So what will be mx lambda? E raised to power, it will be e raised to power lambda square sigma square by 2. Correct?
Yes, sir.
So what is the these things? 1 plus x. So 1 plus x means not, so here sigma square instead of sigma square in the question it's a 9, right? So it will be 3 square, right? Okay.
Yes, sir.
Okay. So it will be 1 plus x. This is x plus x square. So x square means what? Lambda raised to power 4, 3 raised to power 4 divided by 2 factorial into 4. Are you getting?
Yes, sir.
See what is e raised to power x? 1 plus x square by 2 factorial, right? Plus so on, right? So instead of x, what we have? 3 lambda by 2, right? Not 3 lambda by, it's a nothing but it's a e raised to power 3 lambda square by 2, right? This thing is we have, right? So 1 plus x. So x is 3 lambda square by 2 plus x square. So 3 lambda square by 2 whole square, right? Into by 2 factorial, right? Plus x cube divided by 3 factorial, right? Plus so on.
So
Okay?
yes, sir.
Right? So it's a 1 plus, it will be 3 square lambda square by 2 plus 3, no, it's a 3,
3 to the power of 4, sir.
yeah, 3 is for 4, lambda is for 4, divided by 4, right?
4
Into
4 into 2
factorial.
factorial.
Correct? Plus,
Yes.
what will be the next? Next, it will be 3 raised
27
to power 6,
6.
lambda to power 6 divided by 8 into 3 factorial, right?
Yes,
So
sir.
on.
Sir. Yes, sir.
So it's a 1 plus 3 square into lambda square by 2 plus 3 raised to power 4 divided by 2 factorial into lambda.
Sir, 4 can be
Plus so on, right? Now. So what should be the next? 1
you have to
plus.
bring it to that
Correct. We
factorial,
have
sir.
to.
2 factorial
Correct.
means
For
1
the
into 2 into 4 is there. 3 you have to multiply and divide.
correct. So for the getting the fourth moment, we need to coefficient of lambda raised power 4 divided by 4 factorial, right? So here we have lambda raised power 4, but we don't have 4 factorial. So what we can do, I can multiply it by 3 in the numerator and denominator also, right? Correct?
Yes, sir.
So it will be 1 plus 3 square lambda square by 2. So it will be 3 raised power 4 into 3, and I will get lambda raised
Lambda
power
to
4
the
divided by 4 factorial,
4
right?
factorial. Yes, sir.
So this will become what?
That is the fourth moment.
This is the four.
That is the
This will be 3
coefficient.
into. So what
Coefficient
is the
of
correct? What is the coefficient of lambda raised power 4 divided by 4 factorial? That means fourth moment, right? This will give you fourth moment. What is this? 3 raised power 4 into 3. What is this? 339, 9, 3, 27, 81 into 23, right? So 3, 243 is the answer. Is it okay for everyone?
yes, sir. Everyone got the answer.
Okay, everyone got the answer the same. Okay, so last
Sir,
slide is about, yeah, thank you, and put more efforts to learn for this one. Yeah, okay, sir. Yeah. So that's all about your solving the
sir,
session. Yeah, please.
sir, what is the significance of moment 4, sir?
Moment.
So moment, sir. Fourth
Okay,
moment.
basically,
What?
okay, what is the
He
moment?
is asking about fourth moment.
So here it's just a question about what is the fourth moment. Okay, it's a okay. If you are asking about the significance of MGF, so MGF is basically it generates the moment. Okay, so see what is expected value of X. So expected value of X is nothing but first moment of your distribution, right? Expected value of X square is the second moment. Normally we are dealing with the first moment and the second moment, like means we are dealing with the mean, we are dealing with the variance. Okay, so if you study see, that's not in the course here, I think. If you will learn something, it will give you some betas means some kurtosis, skewness. So while you will learn coefficient of kurtosis, so it will give you something mu4 divided by mu2 square, something like that. So in those situations you need the fourth moment, third moment. Okay, so just a basic funda here is MGF generates the different kinds of moment: first moment, second moment, third moment, and like that. Okay.
Okay, sir.
Yeah.
Sir,
Okay.
also
So
one more doubt, sir.
yeah, please.
Sir, sir, e to the power of lambda x can be written as 1 plus lambda x plus lambda square x square by 2 and so on, sir.
Correct. By 2 factorial.
Yes, sir. Is there any proof, sir? It is a theorem.
Proof. Okay, it's not kind of theorem. See, you know the expansion of e raised power x.
Yes, sir, but I don't know the proof, sir.
Okay. So proof. I'm not going to do right now. So what we can do, I can write down the thing, proof, and we'll post on the discourse. Okay.
Okay,
What
sir.
is the
So
expansion of e raised power x? Is something mathematical analysis kind of things. So
okay,
you to
sir.
just keep in your mind that expansion one. Okay, is this clear, Prasad?
Yes, sir. Thank you, sir.
Okay, thank you. Okay, so let me stop the streaming. After that, I think we'll discuss the general doubt. Okay.